Hi everyone, I am making a video about chi-squared. Chi-squared is something that it may show up on your AP, but if it does, it would be a free response and maybe one multiple choice question. It might not be a free response at all, but it might be, and if it is, it's actually a big inference procedure. So let's get going here. There's a few different type of chi-squares. There's chi-square goodness of fit. This one is the most popular, most common one on the AP exam. It's called the chi-square test for association or independence. So I'm going to write that in on the top here because this, oh, by the way, this should be in your notebook, chapter 11 notes day 2. Chapter 11 notes day 2, chi-squared test for association independence. So it's called a chi-squared. Remember, chi is this big X squared. It's a Greek letter chi, C-H-I. Some people say chi, but I say chi. Squared test for association or independence, either one. Okay. So here is a question, and let's see what we could do here. Example, does background music influence what customers buy? One experiment in Europe compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered the entree. So they want to know, is there a relationship or an association between what we're listening to and what we order at the restaurant? Now, in the past, for our last chapter, we did 2 proportion z-test. And 2 proportions would be appropriate if there were only 2 treatments here, like French music and Italian music. Then we could have done the p-hat for French, the p-hat for Italian, and we could have done a 2 proportion z-test, and the null hypothesis would have been p1 or p French equals p Italian. The alternative could have been p1 is not equal to p2. But because there's 3 different types of treatments here, no music, French music, and Italian music, we have to kind of take into account there's like a lot going on here. And so if you look down below, there is a two-way table associated with this. And this is a two-way table that we've seen back in the probability unit. So basically back in even in the beginning of the year, we did a segmented bar graph to show if there was a relationship or not between the variables. These are 2 categorical variables, and there's a row variable and there's a column variable. The row variable is the one that's going across, which is the entree ordered. And the column variable is the one that's going up and down, like a column in a building, like the White House. And that's going to be your type of music. So if you look without the totals, there are 3 rows, French, Italian, and other. And there are 3 columns, none, French, and Italian. So this we call a 3 by 3 matrix, or a 3 by 3 two-way table, where there are 3 rows and 3 columns, again without the totals. Now notice if you look on the bottom right, they do have all the totals, and the total in the sample is on the bottom right, and that was 243. So just to reacquaint us with a two-way table, remember there's a row variable, a column variable, and then there's a total on the bottom right. We can find the probability of the row, the column, or the total. So in this case, if we wanted to do our null hypothesis, the null hypothesis is always a statement of no change. HO means no. So in this case, the no change we would be saying is there is no relationship or no association between the music and the entree ordered. There is no association or relationship, we could say, between the music played and the entree ordered. And because this sample was taken at this restaurant, we would say at this restaurant. Okay. Another way that we could have written this is using the word independence or dependence. We could say entrees ordered are independent of music played, meaning there's no relationship between the 2 variables. Now, the HA is going to be that there is some kind of relationship because we want to take a stance on that one thing is impacting the other. So there is an association between music type and entree ordered. Or the other way to write it is the entree ordered is dependent on the music type. Entree ordered is dependent on music type. Now, the reason why this is kind of different than everything we've done in the past is because these are kind of more general sentences. We're not using symbols here. We're not using mu. We're not using p, which are parameters. We're kind of just making a general statement here about is there a relationship? Because the problem is that there's actually 9 cells in the table. 3 by 3 is 9 total cells. So we're not going to really list out every single proportion because that would be just way too much. So instead, that's why we're just saying, is there no association? And there is an association. I remember HO means no, nothing going on here, no relationship. All right. So now what you want to look at here is you want to look at that we have the table that we have is what was observed. So notice here it says these are the observed counts or what actually happened in the sample. So I want you to write down besides the word observed, we can write the word actual. So just like when we're doing our residuals for our y hat equation, this is like what actually happened versus what was predicted to happen. The same kind of concept here. These cells are what actually happened on this sample. And then it says, can we calculate the expected counts for the table? So they're asking me, can we calculate what was expected or predicted? So you guys know back when we did residuals, and we reviewed it recently, expected or predicted was like y hat, and what actually happened was y. So similarly here, this is what actually happened on the left, and what was predicted to happen is what they want us to calculate. So now what we could do is we could either calculate these expected counts by hand, which is a lot of work, and I'll show you how to do it for maybe 1 or 2, but then I'm going to show you how to use the calculator and how it's so much easier. So if we scroll down here, it says calculating expected counts by hand. So to calculate the expected counts for each cell by hand, what you would do is you would do the row total times the column total divided by the total for every single cell. So there's a total of 9 cells. So technically if I was doing this by hand, I would have to do this 9 times. Row total times column total divided by total. Okay. So I'm going to show you guys how to do maybe 1 or 2 here, and then I'm going to go to the calculator for the trick. So let's say I wanted to do this top left-hand corner, which I'm going to highlight here in the color aqua. Okay, so this is French and none. All right. So if I wanted to do French and none expected value, I would have to do row total times column total divided by total. Okay, so I'm going to do it over here in this little box. I'm going to do French intersect none. Remember the intersection is the and, which means where they overlap. Okay, so the row total for French is 99 because there's 99 total French entrees ordered. The column total is none. So that would be the 84, no background music. And then the total is what's on the bottom right-hand side of the whole table, and that's 243. Okay, so if we were doing this by hand, we would go to our calculator and we would do row total times column total divided by total. So we would do 99 for the row total times 84 for the column total divided by 243 for the total, and I hit enter. I got a fraction. I'm going to make it a decimal, so I'm going to press math number 2 decimal and hit enter. I got 34.222. So I'm going to write the expected count next to the observed count, kind of just like hovering on the right hand side of the cell. So 34.222. Okay, and that's a decimal. Boop. All right, so now let's do the one on the bottom right. I'll highlight this one in pink, and this is going to be Italian and other. Okay, so I'll do it over here. Italian and other, intersection. So Italian row total times column total divided by total. So the row total for other is 113. The column total is Italian, 84. And then the total is the same, 243. So I did 113 times 84 divided by 243. So let's do that now. 113 times 84, enter, divided by 243. Sometimes this is quicker. Okay. So I got 39.06. So I'm going to write that in next to the cell, 39.06, okay, for this one. So you're probably thinking like, why would I want to do this by hand? This is super, super annoying. I don't want to do it by hand actually, because that's too much work. So let me see if the calculator steps are on here. Notice down below, by the way, it says AP exam tip. If we're doing the chi-square test for goodness to fit, the expected count should not be rounded to the nearest whole number. While an observed count is a whole number because that's something that actually happened, the expected count is not a whole number because it could be a decimal. It's kind of like the average of something, so you can put the decimals like I did above. So let's see if the calculator steps are on here. I think it's going to be on the next cell. Nope, doesn't look like it is. So I'm going to show you guys how to do this on the calculator. You need to use the matrix button, which I don't know if some of you ever have seen it before. So on calc, I'll write this over here. We need to go to the matrix. So I'm going to pull up the calculator. And we're going to find the matrix button, which is second x to the negative 1. Second x to the negative 1. And this is going to be the matrix button. Okay, so first, let's find it. Second, x to the negative 1. And now you're going to see a list of matrices from A through I, and we're going to choose matrix 1, but we're going to edit it. So you're going to go over to the right to edit, and then you're going to choose matrix 1. Okay, so go over to the right to edit, and then you're going to choose matrix 1, which is going to be letter A. Okay, now it's going to ask you how many rows and how many columns your original values had in your original table, which is your observed counts. So you're going to enter your rows and your columns of your original observed counts. And we had 3 rows and 3 columns, if you remember. So I'm going to go back up here. Remember, we had 3 rows and 3 columns, 3 entrees ordered, and 3 types of music. So to enter this, I'm going to press 3, enter, 3, enter. And this is going to be a 3 by 3. So remember, rows first and columns second, row by column. So now what you're going to do is you're going to enter in all the observed counts that you see happened from the table. So starting with 30 on the top right, you hit enter, and it's going to default to go left to right. So just when you hit enter, make a note that you're going across and not down the first column. You're going across the first row. So this is French. So 30, 39, and 30. And you're not going to put in the totals. 30, 39, 30. Now next one is going to be 11. That's Italian. 1 and 19. And then the last one is 43 for other, 35, and 35. All right, so hopefully let's double check that everything's in correctly, and then we're going to proceed. Okay, so the next thing that we're going to do is we have to get our expected counts, and the way we do it is we run the chi-square test. So I'm going to probably run the test twice. I'm going to run it once now to get the expected counts, and then I'm going to run it again when we need to get our chi-squared test statistic, okay? So what we're going to do is we're going to press stat, and I'm going to write this down as we go. We'll go back down here. We're going to press stat. We're going to go over to test. And we're going to choose one of the only ones that we haven't used yet, which is called the chi-squared test for association. I don't know if it says it or if it just says chi-squared test. Let's see. So let's press stat, go over to test, and then you could scroll up or down. Let's choose up. It's a little easier because it's toward the bottom. So you're going to see C and D, C for cow and D for dog. You're going to choose a regular chi-square test, which is letter C for car. So choose C, and that's chi-squared test. Choose it. So let me write that down. C, chi-squared test, not goodness of fit, because that's the other test. And then it's going to ask you where are your observed counts, and you're going to say matrix A. where your expected counts. You're going to say, I want them in matrix B. So you don't really touch this, you just leave it there. And then you're going to hit calculate or draw. We're going to start with calculate. We're going to hit enter. Now this information here, we're going to use on the next slide. Like I'm actually just going to like bank it for now, but I want you now to go back to the matrix key and look in matrix B. So to do that, you press second x to the -1, and look, matrix B now has something in it because running the chi-square test actually calculates the observed counts for you for matrix B. So if we hit 2, and we could either hit enter on the home screen, you're going to see all the counts here, or I could show you, you could go into the matrix and look at them that way. So if you go back up to my 2 that I calculated by hand, do you remember we calculated, we calculated the first one by hand, which was 34.22. That was French and none. And if you look on here on the top right, that's corresponding to 34.222, French and none. If I look on the right hand side here at Italian and other, go to the right with your cursor, you're going to see the one I got, 39.061 on the bottom right, okay? So what they want you to do is actually copy down all 9 expected counts. You can decide if you want to write them in your cells like I did, like right next to the observed counts, or if you want to copy down a totally separate table for yourself of observed counts. It's up to you. I'm kind of lazy, so I'm just going to write them in a little bit for you. I'm going to show you, I'm going to write 10.7, 39.06, etc. So technically I should really be writing all 9 of these in, but for the sake of time I won't, but just know that if I had looked on my screen here, they would be there. The other thing you could do is you could press second matrix again, x to the -1. If you go over to edit and you go down to matrix 2, you could see them actually a lot nicer here in the screen. And because I can do this, I'm going to drag and drop this over here. And I'm going to show you guys, like, here are your observed counts right here. So I would just want to actually label this and write observed. I'm sorry, expected counts. Okay. So there you have it. So here are your observed counts and your expected counts. So now I'm going to keep it moving here. Going to the next page here. We're going to go now to the part where we have to do our chi-squared test statistic. Oh, sorry, we forgot to talk about assumptions. I don't know if it's on this page or not. Let me see. Doesn't look like it. So for the assumptions, one of the assumptions that we have to check for the chi-squared, really one of the only ones, is that all the expected counts are greater than 1 and no more than 20% are less than 5. Well, if you look at all my expected counts, which I'll pull up right here again, all of them are greater than 1 and greater than 5. So as long as they're greater than 1 and greater than 5, you don't really have to do much. So I'm just going to say all expected counts are greater than 5 and 1. Greater than 1 and greater than 5. Great, because otherwise we would have too small of a sample size and technically we would not be able to proceed. Also, you should check that it's a simple random sample. Let's see if it was. It didn't say, so we probably should check that too. All right. So anyway, remember when we're doing phantoms, we eventually get up to the step where we have to do the name and the test statistic. Okay. So the name of this procedure is called a chi-squared test, which is what I started with, chi-squared test, and it's for association or independence. You can write either one or both. It's up to you. But if you forgot the name of it, if you call it a chi-squared test and you don't write for association independence, you're going to get full credit because it is indeed a chi-squared test. So that's kind of a way to get around it. So now the formula for the chi-squared test statistic is actually on the reference sheet. It's right here. So you don't have to memorize this. So I'm just going to show you guys really quick where to look. You're going to look under your inference. Where did it go? Oh, it's right here. Under standardized test statistic and confidence interval, chi-squared test statistic is right underneath here. So that's good. Let me snip it. Okay. All right, so that's good because you're just going to copy down the formula from the reference sheet. So here it is right there. Okay. And then let me just write down reference sheet so you know that it's not something you have to memorize. Copy it down. So now what we're going to do is we're going to plug in some of our cells and just show a little work here. Okay. So you don't necessarily have to show all 9 cells because that's really annoying. So you could show the first one and then a dot, 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 and the last one. Okay, so the first one we're going to do every time, we're going to do observed minus expected squared over expected. And then we're going to eventually add them all up. All right. Observed minus expected squared over expected. So let's do our first one. Observed. So this is going to be the one from the top left-hand side that we did first. That was French and none. So the observed was 30 and the expected was 34.222. So we're going to do 30 minus 34.222. Okay. Observed 30 minus expected 34.222 squared over expected 34.222. Now I'm not going to do the rest. I'm going to put a plus sign and then I'm going to do a little dot, dot, dot action. And then I'm going to do the last cell, which is the one I did on the bottom right hand side. And that was other, I think. So I'm going to do observed minus expected